Hello, my name is Farshid, and thank you for watching our demo video for ProFuN TG tool.
So in this video, I introduce you some of the very basic features of our ProFuN TG tool. And at the end of the video, I provide you with some links for more detailed information. The goal of ProFuN tool is to provide programming environment for wireless sensor network. In this programming environment, the idea is to let the programmer specify the application of the network and program the network as a whole rather than per sensor node. And this allows the programmer to focus only on the application services the network provides, and it abstracts away the details such as communication protocols and so on. Okay, so let's start. I'm visiting our preview page. This is public for you. You can just go to this address and visit this page. Here, there are three main views in our tool that you can see. Task sheet view, network view, and application view. So in the task sheet view, you can specify the application of your network. In terms of abstract task graph, I will explain more in details as we go on. So on the left pane here, you can see the tasks that you can use to construct your task graph. So these are sensor tasks and actuator tasks and processing tasks. The processing would be input, output, and functions. Okay, so now let's look at the network view. The network view shows you the placement of the nodes in the physical network. So if you are actually deploying a network, then here is your environment, then each sensor location is exactly where you place them in the actual network, in the actual environment. Each sensor node is represented with a circle, and a square represents a gateway node. There are links between the nodes. Each link, here you have a number that represents the link quality of this, which is average link quality. And there are some details hovering in a box above each node. These are the properties of the node. For example, the address of the node and the serial ID of a node, or whether it's a gateway or not. Okay, so what you're seeing here is a deployment of 17 sensor nodes in the IT department of Uppsala University. Basically, every step of the design, deployment, and maintenance of this network is done using ProFuN tool. And we're collecting the data, and I will also show you how this collection looks like. Okay, so now let's look at a simple example, and we create a simple example together in this video. For doing that, I'm going to switch to our localhost version. So let's say we are interested in measuring light intensity at our apartment. In that case, I'm going to drop light sensor task here, and I'm going to collect the light sensor data using the data collector, and simply say that any data created by the light sensor should go to our data collector. Now, if you double click on a task, you can see some properties, and you can set some properties. For example, constrain a task to some specific node, or you can say how many times a task should be deployed on the network, on the nodes, and there are more properties that we can set. Same as that window, we can also press Control Space and see those properties set here. So now let's go to network view, and I'm going to quickly load a background that represents our environment for basically our apartment map for placing our nodes. So I'm going to upload this photo of the apartment. There we go, yeah. And then we are going to place sensor nodes in this map. Okay, so now let's place our sensor nodes. For that, I will choose a sky motor sensor node. I'll just drag and drop it here in room 2. As soon as I do that, you will see there is a square. That means it's a gateway node. The first node will always be a gateway node, and then you will see a little triangle or an orange triangle up here. That means we have not configured the node yet. By configuration, it means you can double click and open this window and choose your configuration. By configuration, we mean create a template. A template is basically specifying the properties of the network, what kind of sensors it provides and what kind of actuators it provides. I'll just go ahead and call it sensor. So this will be my template, and I can use it on every node without reconfiguring one by one. So let's place OK. Then you see that the triangle disappears, and now I can use this node. For creating more nodes, I'm just going to press Ctrl C, one node copied, and then press Ctrl V to paste one node in the network. And then I'll just drag and move my node around the network. So let's say this node would go into room 3. I create one more and just move it around in different rooms. I want to put one node per room. So one more node goes to room 4, for example, and let's place one in room 5 and one in room 1. Now we have a simple network, as you can see, but we can't distinguish yet between different nodes. They all inherit this sensor template. So I'm going to click on this node and on my gateway, and I choose an address for it. This will help me to distinguish the node later when I'm looking at the data collection graph. So I'm going to give an address that represents which room it is located in. So this node is in room 2. Let's just move it a little bit so that it can be visible. It's in room 2, yes. So then I'm just going to say address 2, and same for every other node. Address 3 and address 4 here, and address 5 and address 1. It's important that the address is unique. Then what I'm going to do next is that I want to allocate the tasks for the nodes, right? So I'm just going to press allocate. This would run the allocation algorithm using constraint programming, and you can see, okay, light and collection is allocated to this node. But you can notice that the allocation is only on one node now, and that's not what we want. So we go back to task sheet view and double click on light sensor, and that brings up this window again. We choose frequency to be on each node, right? Before it was once per the network. Now we just set it on each node. And then immediately you will see frequency per node. Then you might wonder what will happen to data collector then. Data collector will say inherit from upstream, this is the upstream. So the data collector would also be once per node. Then we say okay, and let's redo the collection here. Okay, now you will see for every sensor node we have light task and data collection task. So now that we are ready, let's run the simulator and see how that looks like in the simulator. I'm going to press start simulator, and this will start building a firmware image for each sensor node, and then using Kuja we simulate this network. Okay, now that the simulator is started, let's go look at the simulation, how that looks like. So if I'm going to make this a bit visible for you, let's bring it in the middle, yes. So that's actually our 5 nodes, right? Then let's look at the output here. And I'm going to pause it right now, pause simulator, so that we can look at the current information. You can see that first of all the light output value, yes, we got it, and then we collect it using the collector task. So this is the light sensor task, and then this is the data collection task. And then these data are forwarded or sent to from node 2 to node 1, and we can see, yes, the network is actually functioning and we have the data. So now it might be interesting to look at how the graph of this data, how does the data look like in time. So I'm going to continue the simulation, and I'm going to the graph.html here. This is a link to a file that we have locally, and it automatically updates the values of the light sensors. And then here you can see light 1, 2, 5. These are exactly the same address as we define here for each sensor. Address 2, 3. So that would be basically room 2, room 1, room 2, and room 5. Then you have, this is the each light values. This one is average values, and similarly here excluding the faulty nodes, because we have some algorithm to detect faulty nodes as well, and also the number of non-faulty nodes here. It should be 5, which is correct at the moment. It is 5. So that's how the data collection would look like. You can also query this information here. So if I go to this address, I can just see the raw data, which is very useful if you want to write your own data visualization or data collection scripts. Okay, for the last part, I would like to show you how do we maintain constraints while running a network, and how does this tool support such feature. So for this example, I'm going to just easily load it from our library. So you can go to import tasks from library and choose realloc. This would automatically create the task sheet view, which is a temperature sensor sending data to heater actuator. And in the network view, we have 4 sensors. So we have a temperature sensors at 1 here, and we have the heater actuator here, and we have a gateway here. So for this example, let's just press allocate and see what happens. Okay, so we have a temperature here and the heater, of course, because this is a heater, the heater task must be allocated on the heater. When I double click, you can see that it is actuator template, and under the actuator template you can see that it has alarm and it has a heater actuator. So let's run this in the simulator. Now that the simulator is working, let's assume that the link between the sensor and our actuator is going to fail. So to do that, I'm just going to move this node away until I see that the link is broken. Now that you don't have any link between sensor and the actuator. So what we expect now is that the network should recover from this failure. And that means the network should reallocate the temperature task on the sensor, on the other sensors that is available in the network. So in order to do that, we're just going to wait for a while and see what happens. Exactly. So after a while, you will see that the system detected a fault, and due to the fault, we reallocate the temperature task on another sensor. So now you can see we have temperature, heater, and this sensor is just rendered faulty. Even if I return it back to close to the two nodes before, I will still continue running using this node. There are a few important notes to mention here. First of all, the tool does not need to recompile the image in case of a link failure or a node failure. So you don't need to wait for the recompilation, redistribution of the firmware image. This is done on the fly. So there are some simple things that I can also mention. The save button will save all your work here. And then there is a deploy button. Deploy button is for when you actually have a physical node and the gateway. And this allows you to deploy the image to the sensor nodes. There are some options here you can set. For example, under simulation, you can choose the radio medium. You can choose transmission, interference range, and some other information there that you can set. Under task allocation, as I showed you before, you can change the objective function and program a new one if you need to. Under network model options, you can choose how this delay distribution is defined, basically. These are more advanced topics that you can read about it in our tutorials. Under communication option, you can choose glossy. This is a more advanced link layer protocol that we are also working on right now. There are other things, for example, visual option. You can choose the background image for your network, and then you have the library. You can export your work, and there are some other information like the keyboard shortcuts that I mentioned a few, and you have the documentation. Here you can see all the tutorials about starting from basic examples to very advanced tutorials that you can go later and look at it and use this as your resource for information. Most of the features are explained here, and you can also see that the architecture here, this is a bit more advanced compared to what we published earlier. Furthermore, you can visit our web page. This is the tool web page in the department. The links I've mentioned earlier, they are both here, these two links for the documentation and the public review. So you can further look at our publications and look at our members and probably contact us if you need to. Thank you very much for watching this video.